Okay, I'm going to do a problem on how to calculate uh, probabilities of wait times for waiting lines or for a waiting line system such as at a bank or a drive up on McDonald's or whatever. How to calculate the probability you'll wait for a certain amount of time using something called the exponential probability distribution. So let's just make up a problem. Let's just say the service times are 46 minutes, and are uh, exponentially distributed. Okay, so that's what we're given, and so we'll use mu as service time. So let's I'm going to go ahead and I'm going to insert the actual symbol. I'm going to go to symbol. And the Greek and Coptic mu is right here. So I'm going to click on that and go insert. And so that means mu is, let's say service times are, let's say I'm going to change this, 46 customers per hour. Let's do it that way. Because service time is how many, and instead of service time, I'm going to call it service rate. I'm going to do this the way the book does it. So I want to make it very similar to this problem here. Okay, so we'll say the service rate is, sorry about the mistakes, guys. I'm kind of making up this problem as I go. So the service rate is 46 customers per hour, and we'll say is again. Well, we'll just say R, that's good enough. Okay, so this mu is a service rate, so I'm going to say 46 customers per hour. So you could also say how many customers it is per minute. So let me copy this down. So 46 customers per minute would be equal to 46 divided by 60 minutes in an hour. And that would be customers per minute. Okay. Guess I should make that plural, huh? Customers. Okay. And so we want, let's say we want to find some things. Let's say we want to find A. We want to find the probability that the service time is less than or equal to, I'm going to put this in a separate place. We'll say less than or equal to 2. I'm going to put a parentheses, or 2 minutes, parentheses. And I'm going to copy this down 2 times. We'll say B, what's the probability the service time is less than or equal to 2.5 minutes. And then for C, we'll say the probability that the service time is greater than 2.5 minutes. Or 2 minutes 30 seconds, in other words. Okay, so those are the things we want to find. And for a solution, first we need to know the equation we need to use. And the equation we're going to use, we would say the probability, let me put it here, the probability that the service time is less than or equal to T is equal to 1 minus E equals 1 minus E. Let me do it this way. 1 space minus space small e. And that's to the parentheses minus. And I'm going to insert the symbol again. Mu. And then close that times T. Oh, times t. Now, another ways we could do it, instead of doing this with a caret, we could, whoop, we could highlight this, and I could go here to the Home tab. Okay, well, let me do that. I'm going to go Control-Shift-F. I guess it won't let me take that to an exponent. Maybe that's interesting. Control-Shift-F, alternate B, or E for superscript. You could do it this way too, okay? Instead of doing the caret. So you're going to take it to that power. Now I'm putting that around in parentheses because if I don't put parentheses around it, when I put it into Excel, and a lot of times you see it without parentheses. You'll see this formula like this. But the reason I put parentheses is because you want to have parentheses around all, you want to do all that at once, and if you don't put parentheses around in Excel, you might have an error. Okay? So when you do this, you got to make sure this t, if this t is in hours, that t has to be in hours. If this t is in minutes, that t has to be in minutes. All right? Also, the mu and the t have to be, if this mu is hours, and that t has to be hours. So all the units have to be the same. So let's go ahead and we'll solve part A now. Now we have the formula. And this is very easy once you have the formula. So you're going to say it equals 1 minus, and the way you do E is a constant like pi. Yeah, it's equal to 2.18 something. It goes on forever. It's an irrational number. But instead of typing that out, we'll just go EXP, and then we're going to put our number. So now remember, we want to have parentheses around all of it, and then I'm going to go minus. And we're going to use minutes because these are in minutes. So we're going to say minus this times 2. Okay? So the probability that it's going to be less than or equal to a minute is, make that percent, is 78.2%. %78.42%. So there's a 78.42% chance that if you have this service rate and it's exponentially distributed, you're gonna get them served in less than 2 minutes or less. Okay. Another way you could do it, I could use the Excel's expo function just directly, equals exp, and see where it says exp distributed. It asks for x, lambda, and cumulative. Well, x is like your t, lambda is like your mu, and cumulative is always going to be yes. So x is going to be this. Lambda is like our mu. And remember, since this is minutes, I want to use minutes, mu in minutes. And then cumulative, you're going to say true. And then that will give you the same answer. That's another way you could do it. Just directly use it without looking it up in a formula. So part B, I copy B down here. Now, what I could do is I could just take these and copy them here. This is the beauty of Excel. And I just double click on this, and I want to make sure this is pointing to 2.5, but since I moved this down 2, I got to move this back up 2. Right? Or if I double click on this one, I got to move this and make it point to that, right? So the probability that's going to be less than 2.5 minutes or less is going to be 85.29. And for part C, so part C is a little bit different. Oh, let me copy that again. Copy, paste. So part C, we already have that if it's less than or equal to 2.5 minutes, it's 85.29%. So remember, the whole probability of the distribution is 100%. So if it's to be greater than 2.5 minutes, it's going to be equal to 1 minus whatever this answer was. Oop. Equals 1 minus whatever that is. So the probability that's going to be greater than 2.5 minutes is going to be 14.71%. Another way you could do it, you could say equals 1 minus expon.dist, and then remember we're going to use this, comma, this, comma, true, close the parentheses, and if we copy the format, it's exactly the same. All right, so these are actually pretty easy once you've done a few problems. They're pretty easy to get. Remember, if it's greater than, you have to take 1 minus because it's always you're always calculating it from the left up. So if you want, remember on a distribution function, the area under the curve is 1 or 100%. So when it's less than or equal to, this formula is cumulative from the left. If you want cumulative from the right, which is this one, 2.5 minutes and everything to the right, you've got to take 1 minus. Okay? Hopefully that makes sense. If you like this video, please subscribe right here. Click my picture. Click like if you could. I appreciate that. That'll encourage me to do more videos. So, thank you very much for watching. Hope it helped. Bye.